Good day. Welcome to One-on-One Maths Private Tutors. We continue with the topic on sequence. This is the second video in a series of 3 videos. Today we are looking at finding the formula for the nth term. So first we are looking at linear sequences where the difference between successive terms is the same. Let's take an example of this question: 3, 5, 7, 9. So the difference between 7 and 9 is 2. The difference between 5 and 7 is 2. The difference between 3 and 5 is 2. We call this a common difference. So what do we mean by the nth term? We have this sequence. We can put it in a table and have position as our n. And then the value at that position is Tn, or term at position n. Positions start from 1 going up. A position is a natural number. You can be number 1, number 2, number 3, number 4, and so forth. So we have 1, 2, 3, 4, and so forth, up to any number n. So position is n, and the term at position 1 is 3. The term at position 2 is 5. The term at position 3 is 7. The term at position 4 is 9. So that's where the n comes from. So we can write this as term 1 is equal to 3. Term 2 is equal to 5. This is the value of term at position 2. Term 3 is 7. The term at position 3 is 7. The term at position 4 is 9. So this is the notation we should get used to. Okay, position and value. Some use un, term at n. This is another notation for the value. Instead of using tn, they use un, but I find tn to be more direct because you can just call it term n. Okay, position is n and term n. How do we use the position to get the term, the value? The position to find the value. That's the formula we need, because at times we can have a sequence going on and on. We might want to find the 50th term. Instead of adding 2 to every term, it would take a lot of time. Maybe we might be asked for the 1000th term. Okay, so to carry out 1000 additions from the first term, 3 plus 2, then we get 5. 5 plus 2, we get 7. 7 plus 2, we get 9. 1,000 times. That might take a lot of time. So we want a formula that is based on the position, so that if we are given a position, the term at position 100, we can use that formula to quickly calculate that term. Okay, because these are the terms and these are the positions. So by looking at this, we can see this 2 is a common number, a common difference. So our formula for any term will contain 2n. The formula will include 2n. Okay, so what are we doing to this? We are saying this position 1 times 2, we get 2. This position 2 times 2, we get 4. This position 3 times 2, we're getting 6. We have 3 here. What do we need to do to get to 3 when we're at 2? We add 1, then we get 3. We add 1 to 4, then we get 5. We add 1 to 6, then we get 7. So we can see the trend. We are multiplying the position by 2, and we are then adding 1. So we can say any term at position n will be equal to 2 times its position plus 1. Okay, for example, If we want to find the 100th term, which is term 100, will be equal to 2 times 100 plus 1. So we first multiply the position by 2, then we add 1. So this will be 201. If we want the 1000th term, what we are doing is looking for T1000, which is 2 times 1000 plus 1, which is 2001. So our table can now be extended. If it goes on and on, if we are at position 100, we will have 201. If it goes on and we are at position 1000, it will be 2001. So that is the term. But it will be difficult to get. It would take a lot of time to get these values if we were using term-to-term relationship. So this is a quicker way of obtaining any values that we want. So using the common difference, which is the difference between successive terms, we can form an equation that will help us to find the term at any position n. Another way is to use algebra to find the formula for the nth term. Let's look at this question. Find the formula for the nth term of this sequence. So we can put this information in a table, n, which is our position, and Tn, which is our value or term at position n. If n is 1, we have 20. That's the first term. The second term is 17. The third term is 14. The fourth term is 11, and so forth. Now we have the general formula Tn is equal to An. Why do we say that? If we say this is a linear sequence, if we take these positions and put them on a graph, if we take this information and put it on a graph, we can see 120. So this is the value or the term. And this is the position 1. Position 1, there's 20. Position 2, there's 17. Position 3 is 14, which is here. Position 4 is 11, which is just after 10 here. So if we draw a line, it would be a straight line passing through those points. That's why they are called linear, because when they are plotted, position versus the value, we'll get a straight line. So we would want a formula for this straight line. We know the graph of a straight line is in the form y is equal to mx plus c. We can see that our x-axis has the position n, and our y-axis has the value which is Tn, the terms which are Tn. So we can say Tn is equal to An plus b, which is the form that we will have for our linear sequence. So things that are varying are the term which is on the y-axis, which we can compare there, and the position which is on the x-axis. So we can substitute now values from our table. So we have term 1 is 20, position is 1, a times 1, plus b, which we don't know. Then we can also substitute for this second term, which is 17 is equal to a times 2 plus b. So now we can solve these two simultaneous equations. Let's simplify them. 20 is equal to a plus b, and 17 is equal to 2a plus b. Okay, so we can say this is equation 1, this is equation 2. from 1. B is equal to 20 minus A. If we take this A to that side, now we can substitute B in 2. So we have 17 is equal to 2A plus 20 minus A. We take this 20 to that side, 17 minus 20 is equal to 2A minus A. Minus 3 is equal to A. So we have A as minus 3. Let's look for B. We can substitute A in 1. So we have 20 is equal to minus 3 plus B. When we take this there, B is equal to 23. So our equation now from here, we have A as minus 3 and B as 23. We can say Tn is equal to minus 3n plus 23. Any term n can be found by saying 23 minus 3n if we rearrange this. So this is the formula for the nth term. We can find any term. So if we are asked to find the 100th term of this sequence, we can just say T100 is equal to 23 minus 3 times 100, which is 23 minus 300, which will give us minus 277. So on our table, if it goes on and we are looking for the 100th term at position 100, we know it's minus 277. Thank you.